All right, everyone, how's everyone doing? Woo! Thanks for coming out on, what is it? What day? Tuesday? Wednesday? Tuesday night. I've already forgotten. There's so much AI news happening that I forget what day of the week it is. But thank you all for coming out tonight. My name is Beyang. I'm the CTO and co-founder of a company called Sourcegraph. We build developer tools for developers working in large, messy code bases, code search, and code AI. And today I'm going to talk about building blocks for making AI work in large, messy code bases. So first off, hello? Oh, all right, that's way better. It sounds, wow. Okay, so first a bit about Sourcegraph. Who do we serve? We serve some of the largest, most complex code bases and the most forward-thinking large engineering organizations in the world. Everyone from folks like Dropbox and Stripe. Maybe some of you took an Uber over here. Maybe some of you have been through a Leidos airport security machine. The whole spectrum of startups trying to move fast and build things to some of the largest, oldest companies that are building software in the world. And so that gives us a unique view into how AI is being deployed into large, messy production code bases. And for those of you who came to the last event like this, you're probably familiar with this slide, but I'm just going to present it again just to frame a bit of the gap, a bit of the dichotomy that we see in the world of AI coding tools. So roughly speaking, there's kind of like two camps of people in the world. There's people like the people on the left who are like, AI is here, AGI is upon us. I don't even write code anymore. I just talk into my iPhone and it writes the code for me. I don't need to hire any developers. My job is done. All our jobs are gone, and we should just embrace the AGI. And then there's other people who are like, well, I'm a professional dev. I work in a large code base. I'm using this stuff, and it's nifty and cool, but it's more of a toy. It often makes mistakes and messes up. So I guess by show of hands, like, who resonates more with the guy on the left? All right, cool. Be honest, yeah. I know I was throwing some shade at him, but I think like there's a lot of cool stuff in the world of AI. Who here resonates more with the guy on the right? Anyone? Okay, this is a fairly even split. Okay, so I think the $100 trillion question, whatever the market cap of like code AI tools is, which one of these people is right? And so a while ago we had this realization, what if they're both right? Well, how could they both be right? Well, I think it might be, what does your universe of code look like? If you're working on like new applications or small side projects or small code bases, AI is working really well for that sort of thing. Greenfield codes, building like simple apps from scratch. That works really well because the LLMs have been trained on a lot of data that looks like that. Meanwhile, if you're working in a large legacy code base, you might have a very different experience. We hear a lot of people saying, oh, this tool doesn't work so well for me because it doesn't understand the patterns of my code. Maybe I have like a special internal language that it's not aware of. And so this is kind of like the two worlds that we're exposed to. And so if you're living in the code on the right here, in a large, messy legacy code base, and frankly speaking, I think 99.99% of the code in the world that has actual users and drives actual revenue is going to be messy and legacy to a certain extent because things get messy as users file bug reports and feature requests. And for that, what we found are not just the LM matters, but prompts and context matter a lot. Because you're essentially in what's known as an out-of-distribution situation. So the data that you're working with, this legacy private code that's in your work code base, is out of the distribution of the training set of these LLMs. Because the LLMs were all trained on large open source data corpuses. Your Stack Overflows, open source on GitHub. And if the code that you're working on was not represented in the training set, then it's out of the distribution. And so you're kind of like, it will try to pattern match the best it can, but it'll make a lot of stuff up, and it generally won't work as well. And so if we look at like the general architecture of basically like 99% of AI applications today, if you squint, they all look something like this, right? Like you have your LLM in the center, you're feeding something to it, and the thing that you're feeding is really a product of two things. One is the structure of your prompt template, And then the second thing is the context that you bring in. So maybe this is like code snippets drawn from your code base, or maybe it's the output of a terminal command, or maybe it's some documentation that you're referencing. If you're using ChatGPT, it's like basically what you're copy and pasting into the window, right? You feed that to the LM and you get some output. Maybe it's code you're asking it to write, maybe it's answer to a technical question. This is kind of like the basic structure of a ton of productivity applications. We view this as sort of a basic unit of reasoning. So each one of these steps is kind of like a basic composable block of LLM-style reasoning, if we can call it reasoning. It's kind of like glorified higher-level pattern matching, but we'll call it reasoning. And turns out you can also compose these into long chains. Actually, anyone know what the technical term is for stacking these while you're trying to raise a large amount of venture capital? Agents, right? Agents. You just stack these reasoning blocks, you call them agents, and then next day you wake up and you have $1 billion in your bank account. But going back to this picture, this is a picture that we think about a lot because this is the basic building block. If you're trying to compose things into longer chains to do fancier things, the quality of the basic building block matters a lot. Okay, so if you think about like the use cases or the form factors that have emerged in AI land so far, you got like your chat, you have your autocomplete, and then you have some agents for building small applications from scratch. And if you plot these on kind of like a 2x2, x-axis is like effortlessness, like how low friction it is. And then the y-axis is like versatility. How well does this actually work on your production code versus just like the open source code that it was trained on? You have chat over in the kind of like left-hand upper corner because it takes a lot of manual effort to do it well. Like the lazy user will just, we see a lot of interesting prompts fed to AI systems. Like the other day, a user was complaining to me like, hey, Cody is our AI coding product, didn't generate this unit test well. And I looked at what they typed into the chat box. It's literally like, make this test better. And so I was like, well, if that's all the context, that's all the structure you gave it, it's going to kind of like do the best it can, but there's not a lot of direction there, right? So it actually takes a fair bit of manual effort to make something like chat work well in your production code, using the styles that you have internally, using the libraries that you have access to internally. And then on the other end of the spectrum, you have things like autocomplete, which they're composed of these units where the template and the context are very predefined. So they're kind of like one size fits all. They don't use a ton of context. They're kind of good for these like local, complete my next line type of things. And what we're really focused on, or what we found is kind of like a sweet spot and underserved so far, is this kind of big area in the upper right-hand corner for large, messy code bases, where it's like, well, I want something that's lower friction. I don't want to sit there and like prompt engineering while I'm trying to ship my feature. But I also, I want something that's fairly versatile. I want it to work well with the context of my production code. And so the building block that you end up creating there looks a lot different than the type of prompting and context you bring in for autocomplete or chat. And so we've been building a lot of features that are tailored to these two use cases. So just to make that concrete, one of the things that we found is super useful, even though it seems kind of like brain dead simple. We've shipped this thing called Prompt Library inside Cody. So Cody is our AI coding assistant. It lives here in an editor. There's also a web application. But the point here is that there's a bunch of prompts that you, as an individual dev, might invest in producing because you might have a problem that you want to solve with some form of AI automation. So in this case, I've written a prompt for generating high-quality unit tests in Go, and I've given it a bunch of like rules and prescriptions for how to do this, such that it will get accepted, a green stamp in my organization. So if I pop over to Cody, I can actually run the output with both these prompts. So I have two Cody windows here. Actually, can you come here and hold the mic while I type? Thank you. So if on the left-hand side, if I'm just using manual chat, I can do something like really lazy. So if I want to generate like a unit test for this, I could just write, generate a unit test. So this is without like the benefit of the prompt library. This is probably what most users would do because you're lazy, you're in a hurry, you just want to get an answer. And this does an okay job, but it's not great. Now, with the benefit of the prompt library, I can pull in the prompt that I just showed you. And then when I hit enter, this is going to take a lot of the prescriptions that I wrote in that prompt without the benefit of like me having to kind of like rewrite all this from scratch. So in this case, it asks it to describe the function that's generating first, because studies have shown that like LLMs do a better job of reasoning when there's kind of like a thinking phase first. Like this is kind of like the reasoning capability that's been shipping in more models recently. And then now it generates kind of like a more thorough test set of test cases, as well as follows the style guides I'm using. Am I about to get swatted? Okay. I thought I would run out of time, but I just wanted to end. If this is of interest, if you have a large messy code base and want to use a tool that's useful, you can go to codey.dev. The middle thing subscribes you to our account on Twitter/X, and then if you want to reach out to me with any individual questions, you can do so on LinkedIn. Thank you so much.